Now let's review our natural logarithms. Recall that logarithms represent exponents. So we can have a log with a base b of an argument x equals y. Notice the base is smaller and lower. Just like an exponent is small and high, our base here is small and low. The definition of a logarithm states that the base of the logarithm, b, taken to the exponent of y, the base to the power of y, should equal our argument, or whatever it is we're taking the log of. Sometimes I call that the swirly-do definition. And we can go back and forth. We can take a logarithm, write it as an exponential. We can take an exponential or an exponent and write it as a logarithm. So again, this is read log of base b of x equals y. Thus, the logarithm equals the exponent of b. That would give us x. The natural log, which we are going to use a lot, has a base of e. And it's noted by lowercase l of n of x. And please note when you are typing in your answers to use a lowercase l for logarithms, not a capital I. Because sometimes when you type it in, the I just looks like this. And the lowercase l also looks like this. And so people can't tell why they're getting it wrong. So the computer only recognizes it as a lowercase l, not a capital I. So be careful. So notice, if we see just ln of x, that's the same thing as the logarithm of base e of x. Also, one of the things I want you to note is if they ask you for an exact answer, that means they want you to leave it in terms, let's say, natural log of 5. This is an exact answer. If they want an approximated answer, they're going to ask you to put it in your calculator and come up with a decimal. So natural log of 5 would be approximately 1.609. In example A, they're asking us to rewrite the natural log of 5 equals x in exponential form. Well, remember, this has an understood e as its base. So if we took e to the exponent of x, that should equal the argument, which is 5. Next, they ask us to rewrite y equals e to the x plus 5 as a natural logarithm. Well, the natural log, that is an understood base e, but we don't have to write that e. And remember, the natural log equals the exponent. So e to that exponent should equal our argument, which is y. And you can always check it. Did we have the base of e to the power of x plus 5 equaling our argument? Yes, we did. So remember, logarithms represent exponents. Now let's recall some of our properties of logarithms. Logarithm of 1 equals 0. This is because any base to the 0 power equals 1. Natural log of e equals 1, since e to the power of 1 will equal itself. Again, using our definition, base to the exponent should equal our argument. Swirly-do. E to the natural log of m equals just m. This one might be a little bit harder to see, so let's consider that exponent of the natural log of m. It has understood base of e, and e to what exponent would give us m back? So the natural log of m is representing that exponent. Well, guess what? We are taking e to that exponent. So e to the natural log of m equals m. The natural log of e to the r would be just r, since e to the r equals e to the r. Oh, I missed one. On this one, natural log of x to the r. We use this one quite often if we're trying to solve for an exponent. This we can move the r to the front and multiply it, r times the natural log of x. It's from the exponent rule. If we have an exponent to an exponent, we multiply them. Natural log of a equals the natural log of b if and only if a equals b. Now the last two we can use if we are solving logarithms or potentially exponentials as well. If we have a natural log of a product, x times y, we can write it as two natural logs, natural log of x plus the natural log of y. This comes from the exponent property, x to the a times x to the b equals x to the a plus b. When multiplying like bases, we add the exponents. And likewise, the natural log of division, a ratio like x divided by y, we can write natural log of x minus the natural log of y. And it is always the top minus the bottom. This follows along with the exponent rule. If we had x over a divided by x over b, we can write that as x to the power of a minus b. Remember, logarithms represent exponents.